The process which we use relies on microorganisms' capability to do an oxidation process or a combustion process. In a combustion process, there is a carbon material which is oxidized by an oxidant, and we have a catalyst. Now, an example here is we have a fuel, which is the carbon material. The oxygen is the air around me, but nothing happens until there's a spark, and the spark is the catalyst. So in exactly the same process occurs with microorganisms, but microorganisms are the catalyst rather than the spark. And also, what's the sort of difference with microbial processes is that they occur at body temperature and also in dilute solutions, and that's quite remarkable for the conversion ability of microorganisms. Now, we tap into that process in our assay, and the inventive part of that is that in a combustion process there is a fuel and an oxidant. Now, when you go to water, the water is normally the natural oxidant, but we have replaced that oxidant by a synthetic chemical substance. So in the course of the biological reaction, what we end up with is a soluble material which gets converted to its reduced form. And we've designed an electrochemical detector which can pick up that transformation very accurately and also very quickly, because we can control the kinetics of the reaction. We can add the different amounts to maximize the amount of biological conversion in a short time. During the assay, there is a conversion of the soluble mediator to its reduced form, and that accumulates as a measure of the amount of conversion which has occurred. Now, when a toxicant comes present, that functions a bit like a spanner in the works. It slows things down, and so the signal is modified by the presence of a toxicant. What we've found with the assay in this form is it's very, very amenable to different forms of bacteria. You can either use pure cultures, which are laboratory grown, or you can take natural occurring organisms from an on-site. And there, the advantages to the measurements is that you're recording a result which is specific to the site in which the organisms have come from, and therefore are particularly applicable to that site. The assay which we've developed has been protected by patenting internationally, and that patent is now operative in the USA, Canada, UK, Australia, New Zealand, Japan, and a selection of West European countries. The versatility of this equipment comes from its speed and the ability to miniaturize the equipment. And we've found it to be very useful for the toxicity assays. We've sped up that process by 60-fold, and we are looking forward to applications to BOD as well. Again, we see that same advantage in speed and in size. We are very proud of this technology, and we're looking forward to the opportunities that that's going to make for us and for our investors in developments coming up in the near future.